The question that we are looking at over here is minimum obstacle removal to reach corner. Now you are on a grid of zeros and ones as given over here, and you need the minimum number of ones, which means the minimum number of obstacles to remove to get from the top left to the bottom right corner. Now the key insight is that moving to an empty cell costs 0 and moving to an obstacle costs 1. So when an edge weights are only 0 and 1, you can use 0, 1 BFS with a deck. And this is how we will solve this problem. So I'll run you through the solution line by line. So we start by getting the grid dimensions. M is the number of rows and N is the number of columns, so the length of the first row. Now we have a distance table. This is how we build a distance table. It's the same shape as the grid. Every cell initially is initialized to infinity, meaning it has not been reached yet. And this is the list comprehension that we are using. Distance equals to grid of 0. So if you look at the constraints over here, which have been provided, starting cell's cost is its own value. So that's what we have declared. Then we have a deck. So it's holding one item, which is a tuple 0, 0. Then we will enter the main part, which is we will go through the queue with a while loop. So until and unless the deck is non-empty, we will proceed and we will take the cell at the front, which means we are popping. And now the cell that we have popped, we unpack it, and this cell R and C, if this happens to be the bottom right corner, then its distance is final, so we return immediately. If not, then we start with a for loop. Over here we are exploring in all 4 directions, so down, up, right and left, and we are computing each neighbor's coordinates. So we take the cell that we popped and then we add it to the coordinate. And now what we're doing is that we have a new distance. The new distance is the candidate's cost for the neighbor via this route. So our cost so far plus 1 if the neighbor is an obstacle, so the grid value, and plus 0 if empty. So then we are checking. So the new distance is your distance R and C and your grid's neighbor distance. So you're checking that if this new distance is less than the distance which is on the grid, then we proceed and we change the distance on the distance grid that we are building. So the neighbor's distance, we change it to the one which is less, right? Now if in the grid the neighbor's distance is 0, which means it's free, right? Then we append it to left, or else if there is cost 1, the other option is just cost 1, this one. If it's cost 1, then we append it at the back. So just remember this, left means it's a free move, we append to the front. If it costs 1, then we append at the back, and at the end we just return the bottom right corner.